أهلا بكم أعزائي طلبة المرحلة الأولى قسم طب الأسنان في كلية المستقبل الجامعة. في هذه المحاضرة الفيديوية راح نشرح لكم هذا PDF الثاني اللي يمثل لكم المحاضرة رقم 2 للفصل الدراسي الثاني اللي هو Sound in Medicine. And after the end of this lecture, the student must know the general properties of sound and physics of stethoscope and the application of ultrasound in medicine. And you must know the audible sound range defined as 20 Hertz to 20 kilohertz. Older people lost the ability to hear frequencies above 20 kilohertz. This frequency is called ultrasound. General properties of sound. You must know that we have some fixed properties related to the sound wave. The sound wave is a mechanical wave. The vibration causes local increase and decrease in the pressure relative to the atmospheric pressure. And the pressure increase called compression and decrease called refraction. Compression and refraction can be described by density change and by the displacement of the atoms and molecules from their equilibrium. And actually we put here the density of the medium, rho, and the velocity here is V, the angular frequency is W, and the specific acoustic impedance is Z. And you can see we can calculate everything related to the impedance Z, which is the specific acoustic impedance, by using these terms. And we have an example here which is actually calculate the maximum sound intensity that the air can tolerate at 1000 Hertz and what is the maximum displacement in air corresponding to this intensity. And you can find the solution here which related to such calculation. It's so easy to calculate these factors here. The most natural sound the air can tolerate without pain is just about 120 dB, and this dB comes from the dB is mean decibel, and it is the unit for measurement the noise. It's actually in engineering with the dB, and where I is proportional to squared B can be used to compare any two sound pressure in the same medium. For two sounds with the pressure differ by factor 2, we get from this equation 20 log P2 over P1, which is can calculated to find the dB amount here. And in fact, when sound waves hit the body, part of wave is reflected and part is transmitted into the body, and the ratio of reflected pressure amplitude R to the incident pressure amplitude depends on the acoustic impedance of Z1 and Z2. So you can find here the equation which is connect between R and Z. For sound wave in air hitting the body, Z1 is specific acoustic impedance of air and Z2 is the S1 of tissue. And if Z1 equal to Z2, there is no reflected and the transmission to the sound medium. And here you can see from the